Okay, a couple of unique features that we'll talk about now is one is the MPS True, what we call True LEL. So this is really when you consider traditional gas detection sensors are accurate for the gas that they are calibrated to. So if you calibrate a sensor, whatever it's a Ballista sensor, an infrared sensor, or MPS, you calibrate it to methane, it'll be very accurate for methane. However, some other sensor technologies will not be accurate to other flammable gases that may be present. With MPS, whilst the sensor may be calibrated at the factory for methane, as you can see, we also offer a fairly high level of accuracy across quite a number of other flammable gases that could be present. So the reason that's important is if you're in an application area where you have more than one flammable gas present, or often perhaps more than one or two, more than a few, in fact, um, the MPS will provide a true representation of the overall gas concentration that's present of each of those of that gas concentration, whereas an infrared sensor or certainly a catalytic bead sensor may significantly over or underreport, depending on the gases that are present. The other unique feature for MPS, which is something that is not shared with any of the other traditional gas sensors, is we offer something called gas classification. Um, so again, going back to the detection principles or the measurement principles, sorry, of the MPS sensors, um, because we are taking measurements of multiple temperature spots within the temperature range of the MEMS sensor, um, we can effectively produce a kind of a fingerprint for each of the different gas classifications. So when I say that, let me just clarify, it doesn't mean that we can provide a fully speciated a gas mix or concentration of what's present. So we can't tell you, for example, that there's 20% LEL hydrogen present and 20% LEL propane present. What the sensor does is it takes a look at the molecular weight and the density of the gas molecules that are that hit the sensor, and it provides a classification based on that. So classification one, for example, is hydrogen only. Obviously, molecular wise, it's very different than the rest of the gases on the list. Um, Class two is a hydrogen mixture, so that will be signaled from the sensor. For example, if you had a mix of hydrogen and methane natural gas present. Classification three is methane, and then four, five, and six are light, medium, and heavy gas molecules. So an area where some of our customers have been quite smart with some of their instruments is they use the digital signal from the MPS sensor, and they effectively only take the signal from class one or class one and class two, from digital signal to provide effectively a hydrogen specific measurement from that side.